And for the next presentation, I would like to invite on stage Rahul Mishra. He's going to talk about communication infrastructure and technology metering applications. Rahul Mishra, COO, Probus Smart Things Private Limited.
Hi everyone, I am Rahul Mishra. Sorry for, first of all, that the time has extended. I understand that you are waiting here for the lunch and also the coffee break. All that got missed. I just quickly, give the presentation over the communication, infrastructure and technology and all that related to the metering applications, because this is the hot topic right now, and which is where in the smart meter, these three pillars are very, very important and crucial. But just to give you a background where I come from, I would like to give you a quick intro about the Probus. We are an early stage company. We recently started, and we have we started our work. We are now working onto the communications front, not only in the RF, but GSM, we are agnostic to communication technologies. So we have worked on Bluetooth, we have worked on LoRaWAN, we have worked on GSM, RF for the last now 10 years. And though our company into the application of power distribution segment working in the last 6 years, and we have about 200,000 devices on our platform, scaling up in the last year or so after the RDSS scheme. And then we have planned to cover more geographies from 3 regions in India to 10 regions, and then covering about, we have a target of about 5 million in, by the next year. During our journey, we got honored and accolades from various forums like ISGF, Deloitte, and other Cisco Launchpad and Qualcomm. So these are our strengths on the Bluetooth, RF, and the LoRaWAN, where we have applications ranging from distribution substations, feeders, and consumers. So anything below 11 kV and 33 kV network, that is where we cover all the assets that lie in there. So we try to automate all the assets and provide that information visibility to the utility so that they can take where exactly the energy losses are happening, where exactly the asset monitoring is required, and how their field force are required to be monitored and make that into process efficient. Then, other than communication, we have strength into our data analytics, where we have applications of software analyzing all of this energy management and field force applications, and the geographical topology about how exactly my networks are behaving. So coming to the agenda points, these are the 3 topics that I have taken into today's topic is communication, which is a backbone for the smart metering application, which communication to be used for. Now there are multiple communication, like Sir has asked about that, whether in the terrain or mountainous regions, which communication to go for. And even as system level solutions has told us that because of that cost effective solution can be a G3 PLC. So it varies from terrain, it varies on a lot of factors, and which is what I would like to describe here in the communication, that how it is a key backbone to be choose, because unless and until you have the data, you can't operate, analyze the information, or take any actions. And then, are we prepared to upgrade our infrastructure? Are we ready with the team's skill set that we have? Are we have defined the right technical specifications for all the systems that we have incorporated, whether it is HES, MDM, or the meters? Have we defined the right specifications or not? And lastly, I will cover that how we can benefit the maximum from the technologies that we are going to use, be it the meter or HES or MDM solutions, that how we can maximum utilize out of it. So globally, there are 3 prominent technologies which I could find out, and with the major deployments. One is the RF mesh solution, second is the G3 PLC solution and the cellular network. And the LoRaWAN and the NDB IoT are the new entrants to it, and the deployments are going to increase. Certainly they are, seems to be a good technology, and over the period of years, the numbers will quite change as we see the deployments in India as well. And there are various features to it. Different technologies have their own features. Like the wireless technology of RF mesh is good in the dense networks. is low OPEX and is secured and can operate in the low cellular network regions. While if I talk about the G3 PLC, if I have a good wiring network, then yes, it's a very high reliable technology to operate with, and there is a redundancy available essentially in the G3 PLC, so my PLC can switch to the RF network, and which is why it's a bit costly, but it's very highly reliable when it comes to availability of the data. And lastly is the cellular, because globally there is low good cellular availability, and that's why you see the deployments as well low as compared to the other ones, and plus there is a high OPEX which is involved with the cellular network. So what are the key considerations that we should choose while choosing the communication? There is terrain density, performance of cellular network structure, performance of my distribution network structure, whether my wiring is good or not. But the most important thing that I should be worried about, that am I getting the data availability? Because the data is so crucial. Unless and until I use a mix of technology, the data won't be available. If I just rely that, okay, only I have to use RF technology, the 100% data won't be available, and then I won't be able to do the energy accounting, which is a key feature, the key milestone put up by the REC, and the RDSS scheme, that output that they want to seek. Because I do want to cater, I want to have the data of all the consumer meters corresponding to the feeder or corresponding to the DT. Then only I can carry out the energy accounting that I want to do, and then only I can carry out the theft analysis or all the energy losses that I'm able to do. All that can only be possible if I have that 100% data availability, and that only be possible if I have a good communication and a usage of that mixed hybrid technology communications. I also need to, the third factor which is a very important is the longevity of the solution. That whether it's RF mesh or G3 PLC or cellular, the chipsets that I'm going to use or the other components that I'm going to use, are they going to give that support for that 90 months time period, or are they going to give that support for the long duration? Because if I don't have the support for the maintenance of it, I'm going to invest again and again, and that's going to increase the total cost of it. So it's a very crucial factor to have that durability and the support that I'm going to get for whatever communication technology I'm going to invest into it. The second agenda point that I was discussed to is, are we ready to upgrade our infrastructure? Have we thought about all the considerations? So the first is that, have we allocated the right budget to the smart metering segment? For example, if there is an industrial grade laptop is required, and I have taken a consumer grade laptop, that wouldn't work, right? Because my system is required to be there for the 10 years and more. So I need to invest and allocate that proper budget. If I have to see, and if I'm just comparing its value with only the metering solution, then is a orange to orange comparison. I need to see its value beyond metering and beyond billing. So the question that you had about if there is only a terrain region, and if I am only seeing that, okay, whether it's a cost-effective solution, if I just have to see that, yes, the cost benefit won't occur if I just look into the cost benefit analysis only for the metering application. But if I go beyond metering application, if I look into whether I can have a demand response in the future, whether I can link that with the solar panel monitoring data as well, whether I can include the communication infrastructure and couple it with the smart meter distribution substations, all those communication, if I can club together, there might be a cost-effective solution even in the RF mesh solution. So that's how the cost efficiency can be achieved if we look our budget and if we see the value beyond metering solutions. For the team readiness, we need the utilities which have already deployed the different solutions. There needs to be a engagement and proposal between discussing those utilities and exchanging of sessions and ideas, so that the knowledge and the skill sets essentially can be shared. And in addition, there should be a dedicated teams that needs to be allocated for this. I mean, with the smart meter deployment, we are seeing that, yes, there will be some teams, the automation is coming, and with the automation, obviously, the manual work will be removed, but we also see as an opportunity here that there needs to be a dedicated teams to carry out these AMI projects, to run these AMI projects, because ultimately they are the ones who are going to be the owners. And if we don't have in the utilities itself, the teams who are going to understand these technologies of each components of it, the project won't be successful. So this is a critical parameter of team readiness. And finally, all these applications of the components that we are going to involve into the segments, are we going to integrate, or so there are already MDAS solutions which are running and taking the data of the feeders. But have we prepared ourselves to integrate all those MDAS solutions with the MDM solutions where all the data are getting acquired? Because unless and until we do that, we are not again going to carry out the energy accounting, because some feeders will be monitored separately on the MDAS solutions, and some other distribution substations or the consumer meters are going to get the data on the MDM solutions. We need to have all those integrations together, and at least the preparedness should be there from day one, so that we don't face the issue going forward, or we are not going to reinvent the wheel and putting out again and again more infrastructure to just have that integration solution. So all those key considerations or the specifications should be put in place to look into to have those integration solutions. Lastly, that how can we leverage, this is my last slide that I want to cover about, that how can we benefit more from all these smart meters or whatever communications that we are going to implementing today into the AMI space. So I'll give you what Probus is doing in one of the utilities, is that along with the smart meter deployment, we are using RF mesh technology there in that region. We are also automating the feeders. We are using current sensors, voltage sensors, temperature sensors, and all those are wirelessly working on the same RF mesh technology, which is using for the AMI application. So I don't need to invest into a separate communication technology just for that distribution automation, right? So I can use the same cost for the distribution substation automation, and I have coupled it with the AMI communication. That's how the overall cost of the ownership has reduced. And that is what I would like to see, that, okay, how we can leverage more on the communication front to decrease my overall cost. Similarly, if we see beyond, there is a panel discussion scheduled tomorrow in which I'm also one of the panelists, and I'd like you also to be there to see and discuss about that how beyond metering, if we just increase the value of the AMI rather than focusing only to the metering, to the beyond metering space, then my cost budget can increase, and that will help me to put up the materials which are for the long duration, which are more durable, and which will sustain it for the longer period. And that is where I see the applications like energy auditing, demand response, or proactive outage management. If we include all of this into our value systems of beyond metering, that would surely help and increase the budget of the smart meter. And that is where we all should look into it. With this, I would like to end my presentation and open to any questions or queries if you have any. Thank you.
So what communication technology you use when you say you are capturing the temperatures around 80 and you're sending it to MDM?
Right.
So what communication technology are you using?
We are using the RF mesh technology.
Is that not an expensive technology? Because let's say pick up a rural bed, you may have one feeder feeding 20, let's say one feeder feeding 20 DTs. And you may have 30, 40 residents, or let's say 200 or 300 residents, or some commercial establishment. So in that area, is that a viable option to put a RF mesh around capturing the data from a DT and a feeder? Is cellular not a better option for that area?
Yeah, so now it depends that what all different, so if I have to monitor, if I have to see only, okay, only the AMI, right? Only if I'm seeing that only the metering data to be required from the feeder or from the consumer houses, it's an expensive solution. But if I just deep dive into it and see that, okay, do I need to monitor how healthy my feeders are? And that is where I'm saying that I'm adding that temperature sensors, I'm adding that voltage sensors, I'm adding that current CT sensor. So I'm not investing any more into the meters at the feeder level and putting the external sensors there. And all those sensors are also working on the same communication canopy that I have formed for the AMI space. So that's why the overall cost has decreased, because I'm not putting a separate gateway. So only one gateway is also taking the data for all the meters as well as for all the feeder sensors essentially. And that's how my cost has decreased.
Okay, thank you.
Thank you. Good afternoon. Shurjeel from KPDC here. You have mentioned about beyond metering, looking beyond metering, okay? So in that, the third point is outage management.
Sorry?
Okay.
Outage management.
The third point is outage management, okay? So utilities already have SCADA implemented currently, okay? And now you are getting the smart meter side. You have the energy consumption side and the supply reliability side on the SCADA. And you have billing data from the smart meter, plus the current usage in the smart meter, okay? The real-time data from meters. Okay, so my specific question is that SCADA systems and smart meters combined, okay, will that be able to integrate with the current SCADA implementation in the country? Or do you suggest any study in that, whether we need to upgrade those SCADA systems to a level where both can be integrated so that we can achieve the outage management properly?
Yes, sir. That's a very thoughtful question, sir, and very nice to see that. So yes, my suggestion, and because we have worked at that 11 kV and 23 kV network below, and as well as to the consumer. So what we see that, yes, unless and until those two systems are integrated, I won't be able to know that whether if any outage has occurred at a consumer level is linked with that SCADA system. Like if the whole network is down, or whether it's only the consumer system, if a complaint is coming, essentially, so whether only one consumer house is affected or whether the whole network is affected, I won't be able to know unless and until those systems are integrated. And that is where those systems are somewhere, at least that provision in the current MDM system should be there to have that provisioning of integration of that MDM application with that SCADA or some other third-party outage management system, so that we can have one application of the outage management system managing the consumer outages separately versus the network outage management.
Thank you.
Hi, very good afternoon. I don't stand between the lunch and this one. So the main question is, how are you able to do your auditing or from the sensors, the various sensors that you are giving? So now, as per the SBD, there are only 4 digital I's, not even O's.
There are only 4 digital
Inputs that you can seek, but no digital outputs are given. So now, how are you able to drive that particular sensor information into that particular meter? Because you are going to use the meter, right? Or you are going to have some external device that you have pushed it.
So this question is related to that feeder sensors you're talking about?
Very true, feeder or DTR.
Yeah, so this is not a meter. This is not a meter. This is the external sensors that we are putting for the feeder monitor.
So is it okay for the electricity department?
This is a LT feeder. This is not a HT feeder of 11
No,
kV or
even
30
for
kV.
the,
This is below
even for the
DT.
LT side also, now if you look at the AMI SP SBD, so they give that only 4 digital I's are given.
So in the LT feeder in LT ACB, there is no mandate to put up the meters. There is no mandate to put up the energy audit at a LT feeder or a LT ACB level.
So meter is a separate component on a DT or an LT feeder. He's talking about putting an IoT device.
Yes.
Let's say if you have to put a temperature sensor, you have to put that IoT device into the meter where there is a provision of putting it down. So that data is not pulled to the meter, that
Yes.
data goes to the MDM system.
Yes.
So if they have to show those analytics, they will pull data from MDM system, not from the meter.
Yeah.
So meter remains part of the AMI, you're right, meter is part of the AMI scope. So this may be a parallel scope what utilities are
Yeah,
doing.
this is just a LT feeder and LT ACB, you can say health monitoring of that.
So what you were talking about was a tech debt, whether cost we are going to incur now, so that 10 years down the line, we don't face a issue. So similar was my question with regards to your automation of the feeder lines and everything. Yeah, thank you.
Thank you. Okay, I think the times is up. Thank you for your time.